Okay, we are given an exhibit here with 20 different bins or 20 different intervals. We have the cumulative percentage of the sample and we have lower and upper bounds within each interval and the number of observations in each interval. The 10th percentile corresponds to observations in bins, and we can see that we go up to 100%, so the 10th percentile, we could just stop right there. And it's not asking for the observation, because if it was the 10th percentile observation, it would be 21.22. It's asking for observations are in bins. I prefer the word intervals as opposed to bins, but whatever you prefer. Well, we can see it's in 1 and 2. The second quintile corresponds to observations in bins, and quintiles are fifths. So at the 20, at the 40, at the 60, and at the 80, 1, 2, 3, 4, 5. Bins 5, 6, 7, and 8. 5, 6, 7, and 8. The fourth quartile corresponds to observations in bins. And here quartiles, we divide it by 4. So 25, 50, 75. There's 1, 2, 3, 4. Nice and simple. 16 through 20. 16 through 20. The median is closest to. And so we'll find 50. We have 100 firms, so we know it's n over 2 plus n plus 2 over 2. Then we take the average of that. So it would be the upper bound on the 50th and the lower bound beginning from 50 to 55, 46, 88. We see that they're the same, so we don't have to do this. We can just take 46, 88. But if they were different, we would follow this process. We would take these two numbers, add them together, and then take the average. The interquartile range is closest to. Quartiles is fourths, so 25, 50, 75, and 100. And the interquartile range is the uppermost in the 25th percentile and the bottommost in the 75th. So we have 3, 4, 7, 2 and 56, 22. Just subtract the 2, you get 23, 62. Okay, the fourth quintile return for the MSCI World Index is closest to. Fourth quintile return is the same as the 80th percentile. So first thing we're going to do is rank them. So what I've done through here is I've looked for the lowest number, negative 40.33. I put a little X there. I say that's year 5. I look for the next one is year 8. I put an X there. And that is the next one in order. And I just continue on until I've ranked them all. And then from here, we can see that we have 3 and 10 and 6. So this is 8, observation 9, observation 10. And from the pre-reading, we know that if we want to find a particular percentile, it's n plus 1 plus y over 100. And we're looking for the 80th percentile. Our n is 10, so it's 11 plus 80 over 100, or 11 times 8, which is 8.8. So we take the 8th observation and the 9th observation, and we are 80% of the way from 20.65 to 27.33. So take the difference between that, divided by 10, multiplied by 8. And it'll give you 5.376. So if we add 5.376 onto 20.65, you get to 26.026. Now, a word about this. The answer is using an equation from the pre-read. However, as from information from CFAI, the content of the pre-read is not testable. It is what they assume you already know. So that brings up the issue of whether or not you already know this. This is a rather complex thing to wrap your head around. Is why is it 8.8? Why is it not just 20.65? That's the 8th entry, the 80th percentile. There is a limitation on this one, that the smaller the sample is, the more unobvious it is. You have to imagine a sample of 1,467. Well, which one is the 80th percentile? This will help you figure it out very, very quickly. The larger the sample, the more precise this is. It's not really useful on small samples, because on small samples, it's hard to get your head around, well, why is it not 20.65? Why is it 26.026? There is no observation of 26.026. Well, that's because this is really meant for a very large sample of something that is, when you look at it, you say, well, what's the 80th percentile? How do I get there rather quickly? And that's it right there. Okay, this is a really tedious question. I doubt if you would be given anything like this on an exam, only because it just takes so long to calculate, because you have all the individual calculations that you have to do. The fund's standard deviation of returns over the 10 years is closest to. The first thing we're going to need is the average, is the mean return. So you add all of these up, divide by n, you get 3%. Then we take 0.045 minus 0.03 and square it. Then we take 0.06 minus 0.03, square it. You square all of these, and then you sum them up. You'll get to 0.00575. And we know that it is the sum of the squared deviations. That 2's on the wrong side. Let me back that up. The sum of the squared deviations over n minus 1, and since it's standard deviation, we take the square root. So we have the sum of the squared deviations right there. Our n is 10, and it's n minus 1, so it is 9. Divided by 9, take the square root, you'll get 2.5276, or 2.53%. You can also do this in your calculator. Your calculator has a data and a stat function. You hit the 2ND, the second key, and if you look above the number 7 and the number 8, you'll see data and stat. So second 7 puts it in data mode, enter in all of your data, and then second 8 runs through all the stats, and you'll be able to find standard deviation that way without having to do all of these. You wouldn't have to calculate the mean, you wouldn't have to calculate the squared deviations, you wouldn't have to do all of the steps. You just simply enter in your data series under data, and then you use the stat function to find standard deviation. The target semi-deviation of the returns over the 10 years, if the target is 2%, is closest to. So our target, our B, is 2%. And as I said in the reading, I'm not a big fan of using semi-deviation when you set a target. Semi-deviation is you have a distribution, you're saying, okay, give me this deviation. That's a semi. A semi is half. That's a semi-deviation. This is just a target downside deviation. I prefer the terminology target downside deviation, because when I hear semi-deviation in my head, right away I think, okay, you're talking from the mean onwards to the left tail, not some target. Okay, that being said, anything less than 2%. So not here, not here, 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 not here, not here, not here, not here, not here. So 3 deviations. The squares of the deviations, sum them up, and it's divided by n minus 1, because all of these enter as zeros. So you do actually have 10 numbers that you're summing in your numerator, just a bunch of them are zeros. And you get 0.015 or 1.5%. Okay, based on the coefficient of variation, the riskiest sector is, and coefficient of variation, remember the lower the better. If we have a low coefficient of variation, that means we're using very little risk for each unit of return. So the higher this ratio is, the riskier it is, and it's easy enough. You take the standard deviation divided by the mean monthly return. Here we get 0.586. For materials, it's 1.08. For industrials, it's 0.505. Materials has the highest coefficient of variation. It is the riskiest sector based on that measure.